This videotape deals with multiplication and division of signed numbers. Before we start studying multiplication of signed numbers, it would be a good idea to review multiplication of natural numbers. We all know that 2 times 3 equals 6, which is also equal to 3 times 2, since multiplication is commutative. 2 times 3 equals 3 times 2. Both answers are equal to 6. Now, what you might not recall is the fact that multiplication is really a shorthand for addition, whereas this could be thought of as 2 3s. 2 times 3 is really 2 3s. That is, you're adding up 2 3s and you get an answer of 6. Similarly, 3 2s can be thought of as adding 2 3 times. You also get an answer of 6. 2 3s or 3 2s, either way, the answer is 6. We will use these ideas to develop a rule for multiplying signed numbers. Let's make a list of all the possibilities. We could want to multiply a positive number by a positive number, a positive number by a negative number by a positive number, or a negative number by a negative number. We would like to develop a rule that works in all of these cases and which is consistent with the rules that we already have for multiplication of natural numbers. The first example is really 3 times 5. We know the answer is 15. These are really natural numbers. 3 times 5, 15. This could be thought of as 3 plus 5s. You're adding up plus 5 and a plus 5 and a plus 5 for an answer of plus 15. 3 5s, the answer is 15. That's plus 5 added up 3 times. Over here, 3 plus 3 times minus 5 can be thought of as 3 minus 5s. That is, we will add up minus 5 3 times. Minus 5 and a minus 5, same signs. You add up the 5s, you get 10. You put the minus sign in front. Minus 10 and a minus 5 for an answer of minus 15. Plus 3 times plus 5 gave you plus 15. Plus 3 times minus 5, minus 15. Minus 3 times plus 5. Remember, multiplication is commutative, so this is the same as plus 5 times minus 3, or 5 times minus 3. That is 5 minus 3s. Add up minus 3 5 times. Minus 3 added up 5 times gives you minus 3 and a minus 3, that's minus 6, and minus 3 minus 9, minus 12, minus 15. Finally, we have minus 3 times minus 5. Now, this is the hardest one to see. There are a few ways of interpreting this problem. One way would be to recall the idea of the opposite or the negative of a number. You'll remember that the negative of plus 3 is equal to minus 3, or the opposite of plus 3 is equal to minus 3. Okay, let's rewrite minus 3 in this fashion. Here we have minus 3 times minus 5. Let's make the minus 3 negative plus 3, and we'll keep the minus 5. Right? Negative of plus 3 is minus 3, and the minus 5 I just rewrote. Okay, we would like to evaluate this. It would help us in our evaluation if we were to put brackets around the plus 3 and the minus 5. This says multiply plus 3 and minus 5 and then take the negative or the opposite of that answer. But we've already worked out plus 3 times minus 5. Plus 3 times minus 5 meant 3 minus 5s, which gave us minus 15. So this must mean the negative of minus 15, which would have to be plus 15. Let's look at that again. Minus 3 could also be thought of as the negative of plus 3 or the opposite of plus 3. This is what I write over here. The minus 5 I leave alone, but the minus 3 I write as the negative of plus 3. Then I put brackets around the plus 3 and the minus 5. We already know how to multiply plus 3 and minus 5. That's minus 15. So it's the negative of minus 15, or the opposite of minus 15, which is plus 15. Okay, now this is the hardest one to see. Maybe we can look at it in another way. Might shed some light on this. We want to work out minus 3 times minus 5. Let's see if we can't get some kind of pattern going. We know that plus 3 times minus 5, that means 3 minus 5. We already know that that is minus 15. Okay, let's also write down plus 2 times minus 5, plus 1 times minus 5, 0 times minus 5, minus 1 times minus 5, minus 2 times minus 5, and then minus 3 times minus 5, which is the one we're looking for. 3, now look, there is a pattern. The minus 5 is the same in all cases. The number that we're multiplying by minus 5 is decreasing by 1 each time. Plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. This means 3 minus 5s, which of course is minus 15. This is 2 minus 5s, minus 5 and minus 5, which is minus 10. 1 minus 5, which is minus 5. 0 minus 5, 0 times anything just gives you 0. Now look at the pattern that's developing here on the right. To go from minus 5 to minus 10, on the number line, we would move 5 units to the right. To go from minus 10 to minus 5, we'd move 5 units to the right. In other words, we are adding plus 5 each time. To go from here to here, to go from here to here, to go from here to here. To keep this pattern going, to have the whole thing make sense, it stands to reason that the next answer must be 0 and plus 5, or plus 5. To get the answer after, we'd have to add 5 again, plus 10. And to get the next answer, we'd add 5 again, and we would get plus 15. The hard thing to understand is why a negative number times a negative number should give you a positive answer. But if you look at this pattern that we've set up here, it's the only logical possibility. Now let's look at the answers that we have to the 4 problems. Let me cut out all of this extra work here and just transcribe the answers. Plus 3 times plus 5, that was plus 15. Plus 3 times minus 5, minus 15, minus 15 here, and then plus 15. Now we would like to develop a rule which summarizes these 4 examples. A rule for multiplying signed numbers. And the rule is this. Forget about the signs. Block out the signs. Multiply the numbers as if they were natural numbers. Of course, in each case, you would get 15. 3 times 5. Then, if the signs are the same, either plus times plus or minus times minus, then the answer is positive. If, however, the signs are opposite, a plus times a minus or a minus times a plus, then the answer is negative. Let's write this rule down. Multiplication, leave a little space, I'll explain why later. Multiplication of signed numbers. When multiplying, once again leave a space, 2 signed numbers, multiply, leave a space after multiply, the numbers ignoring the signs. When multiplying two signed numbers, multiply the numbers ignoring the signs. Then, if the signs are the same, the answer is positive. But if the signs are different, the answer is negative. When multiplying two signed numbers, multiply the numbers, ignoring the signs. Then if the signs are the same, the answer is positive, but if the signs are different, the answer is negative. Once again, let's look at these four examples. To multiply two signed numbers, we ignore the signs. The multiplication in each case is 3 times 5 gives you 15. Then in the first and the last case, the signs are the same. 2 pluses or 2 minuses, and the answer is positive 15. In the two middle problems, however, the signs are different, and the answer is negative. It might help you to write down the rule in the following form. When you're multiplying a positive times a positive, the answer is positive. When you're multiplying a negative times a negative, the answer is positive. When, however, you multiply a plus by a minus or a minus by a plus, the answers are negative. Same signs, the answers are positive. Different signs, the answers are negative. Let's try some more examples. Minus 4 times minus 7. We multiply the numbers ignoring the signs. 4 times 7 gives us 28. Then, since the signs were the same, both were minus, the answer is positive. You can, of course, just write 28 without the plus sign. It would mean plus 28. Okay, minus 3 times 4, or plus 4, plus minus 2 times minus 4. Here we have to mix order of operations in with the problem. Remember, when trying to evaluate something like this, we move from left to right. First, we look for grouping symbols. If there aren't any grouping symbols, then we perform multiplications and divisions first, moving from left to right. And after we finish the multiplications and divisions, we go back and do the additions and subtractions. Okay? This means that we have here this multiplication to be performed, and then this multiplication, and then we will add the two results. Minus 3 times 4. This is minus 3 times plus 4. We multiply 3 times 4, we get 12. And since the numbers had different signs, negative and positive, we get negative 12. And then negative 2 times negative 4 gives us positive 8. 8 and a plus sign because they have the same sign. Now we would like to add minus 12 and plus 8. When adding numbers with different signs, we block out the signs, we subtract 12, take away 8, we get 4. And then since the 12 was a larger number and it had a minus sign, the answer is minus 4. Okay, let's try some more. 2 times minus 3 times 5. This is really plus 2 times minus 3 times plus 5. We can multiply these two numbers together and then take that result and multiply it by plus 5. Plus 2 times minus 3, the answer would be minus 6. 6 is equal to 2 times 3, and then negative because we have a positive times a negative, different signs. Then minus 6 times plus 5. Okay, this gives us minus 30. 6 times 5 is 30, minus times plus for a minus. Let's try one more problem, and then we'll move on to division of signed numbers. Minus 8 times 5, take away a minus 3. Now, it's very important that you remember the order of operations. We will perform this multiplication first, then the subtraction. Multiplications and divisions come before additions and subtractions. Resist the temptation to jump right in here and say 5, take away a minus 3. First the multiplication, and then the subtraction. This is really minus 8, of course, times a plus 5. The result would be minus 40. It's minus 40, take away a minus 3. But when you subtract signed numbers, what you do is leave the first number alone, change the subtraction to addition, and change the sign on the second number. Minus 40 and a plus 3. We are adding now numbers with different signs. We block out the signs, 40 and 3, do a subtraction. 40 minus 3 is 37. And then since the 40 was the larger of the two numbers and it had a minus sign, the answer is negative 37. Okay, now let's work out a method for dividing signed numbers. It's going to be based on what we already know about multiplication, because when you first studied division of natural numbers, 12 divided by 4 was equal to 3, because 3 times 4 equals 12. Whatever rule we develop for division of signed numbers has to be consistent with this idea. 12 divided by 4 is equal to 3, since 3 times 4 is equal to 12. Let's consider 4 possibilities. We could have plus 12 divided by plus 4, which of course is just 12 divided by 4, or plus 12 divided by minus 4, minus 12 divided by plus 4, and minus 12 divided by minus 4. A positive over a positive over a negative over a positive, and a negative over a negative. Okay, and we want to figure out what the answer should be in each case to be consistent with what we already know should be the relationship between division and multiplication. Now, plus 12 divided by plus 4 must be equal to plus 3, since this is really the same as 12 over 4 is equal to 3. Notice that this checks out, since plus 4 times plus 3 gives you plus 12. Okay? 4 times 3 gives you 12, so this one is correct. Now we want to figure out what should go in here. Whatever it is, when multiplied by minus 4, must give you plus 12. Well, then the answer has to be minus 3, because minus 3 times minus 4 would give you plus 12. Minus 3 times minus 4, 3 times 4 gives you 12. A negative times a negative, like signs, gives you a positive answer. Let's look over here. Minus 12 divided by plus 4. Okay, whatever we get here as an answer must be true that when it's multiplied by plus 4, you get minus 12. So then the answer must be minus 3, since minus 3 times plus 4 gives you minus 12. 3 times 4 gives you 12. Minus times plus different signs gives you a negative. Minus 12 divided by minus 4. Here the answer must be plus 3. Since minus 4 times plus 3 will give you minus 12. A negative times a positive should give you a negative answer. So it seems that the rules for division will come right out of the rules we have for multiplication. Let's look at these division problems. In each case, we were dividing basically a 12 over 4 with signs attached. Now, the answer in each case was 3 with a plus or a minus sign. Now, if you forget about the signs, right, in each case, 12 over 4 gives you 3. Now, which sign should we tack on? When you're dividing two positives, when the signs were the same, the answer came out positive. When you were dividing two negatives, the signs were the same, the answer came out positive. When you had a positive over a negative, the answer was negative. When you had a negative over a positive, the answer was negative. So it seems that the rule that we had for multiplication of signed numbers will also fit for division of signed numbers, if you just change multiplication to division. Okay, and that's why I left space in the original rule over here. This was for multiplication of signed numbers. Now let's write it's for multiplication or division of signed numbers. When multiplying or dividing two signed numbers, multiply or divide the numbers, ignoring the signs. Then if the signs are the same, the answer is positive. But if the signs are different, the answer is negative. Basically, it's just the same as multiplication. Like signs gives you a positive answer. Different signs give you a negative answer. Let's go back and look at the examples. In each case, you block out the signs, and of course, 12 divided by 4 will be 3. Then, when the signs are the same, in this example and in this example, the answer is plus 3. When the signs are different, in this example and this one, the answer is minus 3. We can also write down the rules for division the way we wrote down the rules for multiplication. It's a shorthand way of remembering them. When you have a positive divided by a positive, the result is positive. When you have a negative divided by a negative, the result is positive. But if you have a positive over a negative or a negative over a positive, in either of these cases, the answer is negative. Okay, like signs, the answer is positive. Different signs, the answer is negative. Let's try some more examples using this rule for division. Plus 30 divided by minus 10. We ignore the signs. 30 divided by 10 would be 3. And then since it's a positive over a negative, the signs were different. The answer is negative, negative 3. Minus 20 divided by minus 4. We ignore the signs. 20 divided by 4 is 5. And since they were two negatives, like signs, the answer is positive, positive 5. Now let's try minus 8 minus 4 over minus 2 times minus 6. This is really minus 8 take away a plus 4 over minus 2 times minus 6. This must be a plus 4 that's being subtracted here. Okay. In the numerator, we have minus 8 take away plus 4. That's really minus 8 plus a minus 4. We change the subtraction to addition, and we change the sign on the second number. And here we have minus 2 times minus 6. Okay? Minus 8 and a minus 4. Adding like signs, the answer will be minus 12. Minus 2 times minus 6, multiplying, like signs, the answer is positive 12. Now division. 12 divided by 12 would be 1. Negative over positive, different signs, the answer therefore is minus 1. Let's try another example like that. 6 take away a minus 8 over 5 times 4 minus 6. Okay, this is plus 6 take away a minus 8. We change the subtraction to addition. We change the minus 8 to a plus 8. On the bottom we have 5 times 4 minus 6. Now, plus 6 and the plus 8, or 6 and 8, gives you 14, or plus 14. On the bottom, the multiplication is done first. 5 times 4 gives you 20. 20 minus 6 gives you 14, plus 14. Okay, plus 14 over plus 14 for an answer of plus 1, or just 1. Now let's try some examples involving substitution. In the following problems, we will assume that x equals minus 2 and y equals 3, or plus 3. If x equals minus 2 and y equals plus 3, I want you to evaluate these expressions. Okay. First problem, x squared. The second problem, x cubed. The third problem, xy squared. And the fourth problem, y minus x over y plus x. Problems out on your own. You can shut off the videotape machine and come back as soon as you're finished. Okay, x squared. X is equal to minus 2. This must mean minus 2 squared, which is minus 2 times minus 2. Minus 2 written as a factor twice. This is a negative times a negative, so the answer is going to be positive 4. You ignore the signs. 2 times 2 is 4, and the negative times the negative gives you a positive answer. X cubed. This is minus 2 cubed. Minus 2 times minus 2 times minus 2. First, we can multiply minus 2 times minus 2 and then multiply the answer by another minus 2. Well, minus 2 times minus 2 we've just seen is plus 4. Plus 4 times minus 2. 4 times 2 gives you 8, but the signs are different, so the answer is minus 8. You might notice that when you have an even number of negative signs, your answer comes out positive, but when you have an odd number of negative signs, the answer comes out negative. You can group the negative signs 2 at a time. Every time you have 2 negatives, you get a positive. So if you have an odd number, you'll be left over with an extra negative, which will turn the result negative. Let's try now xy squared. X is minus 2. Y is plus 3. X times y squared minus 2 times plus 3 squared, or minus 2 times plus 3 times plus 3. Minus 2 times plus 3 gives you minus 6. And minus 6 times plus 3, positive times a negative gives you a negative 18. Y minus x over y plus x. Y, remember, is plus 3 and x is minus 2. Okay, this is plus 3 take away a minus 2 over plus 3 and a minus 2. Y minus x over y plus x. A very common mistake is to forget about the minus sign on the minus 2 here. This is y, take away x, but x itself is a negative number, so be very careful when you write this over. Okay, now in the numerator we have a subtraction of signed numbers. We change the subtraction to addition. We change the sign on the second number. In the bottom, of course, we just have an addition. To add numbers with the same sign, you just add the numbers without the signs. So 3 plus 2 gives you 5. You tack on the common sign. To add numbers with different signs, you block out the signs. You have 3 and 2. You subtract. 3 take away 2 gives you 1. The larger number 3 had a plus sign, so the answer is plus 1. Plus 5 over plus 1 for an answer of plus 5. 5 over 1 gives you 5. Plus over plus, like signs, gives you a positive answer. There's one more thing I want to mention about division. Okay, you've probably heard this expression before. You might not have understood what it means. In our mathematics, we don't divide by 0. Let's look at a division problem and see if we can understand why this is true. We never divide by 0. Never, ever, ever. Okay? Let's look at an example. If you have 12 divided by 3, the answer is 4. And as a check on this, we say 3 times 4 equals 12. In order for division by 0 to make sense, we'd have to be able to make sense of the following problem. 12 divided by 0 would have to be something. And it would have to be true that 0 times this something would be equal to 12. In other words, if 12 divided by 0 had an answer, then in order for this to make sense in terms of multiplication, 0 times that answer must be 12. But we all know that there's no number that we can put in here, multiply by 0, and get 12. Okay? There is no such number for which this will make sense. This can't be true for any number. You can't multiply something by 0 and get 12. Therefore, this can't make any sense. Okay? So this makes no sense. This is not defined. And that brings us to the end of the videotape on multiplication and division of signed numbers.